if you'll click on this YouTube link, so we are going to directly connect the video over here. Okay, and from here we have to continue all the topic. Okay, so we are going to start it now. Okay, let's start.
An object. This scale is graduated in centimeters, and each centimeter is divided into 10 millimeters. We know that the smallest measure that can be measured accurately with a device is called least count of the device. Since the least count of an ordinary scale is 1 millimeter, it is not useful to measure the length or thickness of an object with great accuracy. That is, less than 1 millimeter. In such cases, a vernier calipers is used. The vernier calipers was invented by Pierre Vernier in the year 1960. It can measure length less than 1 millimeter. Let us calculate the least count of a vernier calipers. A vernier calipers consists of two scales. One is called the main scale or ordinary scale, which is fixed. The main scale is graduated in centimeter and millimeter. The other scale, which slides along the main scale, is called the vernier scale. The vernier scale is graduated in divisions that are less than 1 millimeter. It is designed based on a principle such that n divisions on the vernier scale coincide with n-1 divisions on the main scale. Thus, the least count of the vernier calipers is equal to the difference between the values of one division on the main scale and one division on the vernier scale. That is, least count is equal to 1 MSD minus 1 VSD. The least count of vernier calipers is known as the Vernier constant.
Okay, now I want your attention here. See, last time what we have studied, I explained you that MSD stands for main scale reading. Okay, so one division, the small division on main scale, this distance is around how much? We can say it is 1 mm. Okay, so this was the smallest value minus 1 vernier scale division. Now how much is vernier scale division? So yesterday I told you that this distance is 9 mm. Did you understand? This distance is how much? 9 mm. The vernier scale is made 9 mm distance, and this 9 mm distance is actually divided into 10 parts. So what you're going to do, you have to find distance between two division on vernier scale. So we want to talk about this small value. So how we can find out? We are going to divide this total 9 mm by 10 number of divisions. So when you're going to divide 9 mm by 10, so what you will get value? 9 mm upon 10, how much it is? 0.9 mm. Hope you will understand. I am taking enough time to make you understand that how we are calculating least count. So just remember this formula. Least count is equals to 1 main scale division minus 1 vernier scale division. So 1 main scale division is how much? 1 mm minus 1 vernier scale is division how much? 0.9 mm. Okay, this is 0.9 mm. Now you have to subtract 1 minus 0.9 mm. Okay. So how much is the value? 1 minus 0.9 mm. Your answer will be 0.1 mm. Okay. Just you can solve this. 1 mm minus 0.9 mm, it is 0.1 mm. And now if you convert 0.1 mm into centimeter, it is 0.01 centimeter. Now one of your friend, okay, she was having some doubt with vernier scale. Okay, so make it clear here. The distance between small division on vernier scale is 0.9 and one division on main scale is 1 mm. So 1 minus 0.9 mm, the answer is 0.1 mm, and that is equals to 0.01 centimeter. Okay, so I think your friend is having doubts, so let me unmute you all, okay, to help you understand if you are having any doubt. Okay, yes, you can clarify your doubt if you
Yes,
are
sir.
having any doubt here.
Sir, hello, sir.
Yes, you can speak.
Sir, there you have written 9 mm and then 0.9 mm only. So, sir, there won't come 0.9 cm.
0.9 centimeter you want to say?
Yes, sir.
Actually 9 mm is 0.9 centimeter only, na?
Yes, sir, but you have written 0.9 millimeter.
See, this 0.9 centimeter is small value on vernier. Can you see this? I am going to mark this. If you can see, I am going to mark it with white pen. So this is small distance, can you see on vernier?
Yes,
This
sir.
small distance is 0.9 mm, and this from here to this vernier caliper, this distance is 0.9 centimeter. What you are saying, 0.9 centimeter is this much distance, not vernier division. Okay, total length of vernier is 0.9 centimeter, but we want to know what is the value of one small division on vernier scale. So one division on vernier scale is only 0.9 mm, whereas 0.9 centimeter is total length of vernier scale that we are taking. Hope your doubt is clear now.
Yes, sir.
Okay, now I want you to all write this calculation that I have done in your notebook, or you can take a screenshot of this. Okay, because it is very important. If this much part you understood, then means your all concept is clear. I'll repeat again. Okay, one of your friend is having doubt, so I'll repeat again. You can see here this 0.9 centimeter is what? Total length of vernier scale. So this 0.9 centimeter I can write as 9 mm. Now this total length of vernier scale is divided into 10 parts. So we are going to divide 0.9 centimeter, that is 9 mm, into 10 parts. So length of one division on vernier scale will be just 0.9 mm. Whereas the distance between one division on main scale, okay, main scale means only this much distance, 0 and 1 mm. Okay, so this much distance is 1 mm. So the formula for list count, what is written? 1 main scale division minus 1 vernier scale division. So 1 main scale division is how much? 1 mm, and 1 means Vernier scale division is how much? 0.9 mm. So if you divide this 1 mm minus 0.9, you are going to get 0.1 mm, and 0.1 mm means 0.01 centimeter. If you want to convert mm into centimeter, then divide it by 10. So when you divide 0.1 by 10, you'll get answer 0.01 centimeter. Any doubt to anyone? You can ask now. Okay, no need to write in the chat box. Okay, one of your friend is saying that so distance between 2 and 3 is 9 division, right? Yes, so distance between 2 and 3 is 9 division, and that is for Vernier scale. Vernier scale is matching from 2 to 9th division, whereas the main scale, okay, on main scale we are having distance that is 5 and 6, and it is 1 centimeter. Vernier scale is 9 mm, but your main scale is 1 centimeter. Okay, the doubt is what is the use of the scale? So if we want to make accurate measurement, for example, if I'll tell that the height of this pencil is 9.5 centimeter, okay, and another instrument, this Vernier, it is saying that no, the height of pencil is 9.53 centimeter. Okay, so here which one is more accurate? We'll say 9.53 is more accurate. So for making accurate measurement, we are using Vernier scale. Okay, right. Yes, Vernier scale is a little bit different than main scale or the common scale that we are using. Okay, hope that your doubt is clear. Any more doubt? Okay. Vernier scale is a part of main scale, and that is 1 mm smaller. Yes, you are correct. Vernier scale is 1 mm smaller than the main scale, that is division 2 and 3, or distance between 2 division centimeters. And that is actually the main working principle behind this Vernier scale. They are taking only 9 mm. So this is what the main principle of Vernier scale is. And this principle only your Vernier scale works. See, one of your friend is saying that distance between 2 and 3 is 9 division or 10 division. So listen carefully. If we talk about main scale, so on main scale, the divisions are 5, 6, 7, 8, these numbers. So here on main scale, the division are 10. Okay. But if we talk about Vernier, so Vernier scale, okay, its 10th division is matching with the 9th division of main scale. This is what I'm telling. The 10th division of Vernier is matching with the 9th division of the main scale. And that's why I think you people are getting confused. Okay, you just remember that Vernier scale is having total length 9 mm only. Whereas on the meter rule that we are having 2, 3, 3, 4, 4, 5, 5, 6, the total division in between them is 10. And that is taken as 1 centimeter. Fine. Okay, hope that your doubt is clear now. Now we are going to move forward. Let's start this.
Let the value of one main scale division be S and the value of one vernier scale division be V. From the principle of the vernier calipers, N into V is equal to N minus 1 into S. On simplifying, the equation can be written as S minus V is equal to S by N.
See, all this derivation that is given here, we need not to understand this. Okay, we have to only understand a formula that least count of Vernier caliper is how much, Just a minute. Okay, just now we calculated list count equals to main scale division, right, minus Vernier scale. Okay, so main scale is how much? Distance between one small division is 1 mm on main scale minus distance between one small division on Vernier scale is how much? 0.9 mm. And now you're going to find the difference between them. Okay, so we will not solve all these hard derivation. We'll simply go with the easy formula, that is list count equals to main scale minus Vernier scale. Main scale division is how much? 1 mm minus Vernier scale is how much? 0.9. So 1 mm minus 0.9 is how much? 0.1 mm. Okay, many of you are not able to subtract this. Okay, so for that they need to learn the basics of decimal. So 1 mm minus 0.9, it is 0.1 mm, and you want to convert it into centimeter. So you are going to divide 0.1 upon 10. Then your answer will be in centimeter. So your mm will get converted into centimeter. Then 0.1 upon 10, how much it is? 0.01 centimeter. Okay, this is one method or one formula. After this we have to learn one more formula, and the formula is this. Okay, we have to only learn this formula. What this is? See, s minus v. S minus v is nothing but the same formula that I have written here. Okay, can you see this? Okay, S stands for main scale and V stands for Vernier scale. So that is S minus V. Just now we did, and the answer is coming 0.01 centimeter. Next is the same formula is written as S by N. Now what is S? Small division on main scale. What is N? Number of division on Vernier scale. Okay, let me tell you what they are trying to say. Okay, just a minute. Meanwhile, you can write this or take a screenshot of what we have done here. Okay, this is the easiest way we are going to do. Okay, we are not going to understand in detail. Done screenshot? Okay, fine. Now we'll move forward. So I want to show you another formula that is given in your textbook. Okay, and the formula is this. Okay, just a minute. This is what the formula is. Okay, list count equals to x by n. Just learn this formula, x by n. Now what is x here? So x stands for main scale. Okay, and n stands for total number of divisions on Vernier, and total number of divisions on Vernier is how much? It is coming 10. Okay, so let me use this another formula for calculating list count. So you can see the diagram now. Let me come up to the diagram. Okay, see, the another formula for list count that I'm trying to explain is, the formula is list count equals to, this is second formula, first formula is over. Now second formula is what? They are telling x upon n. Okay, Now what is X? So X means the smallest division on main scale. So that is actually 1 mm upon N. What is N here? Number of divisions on Vernier scale. Okay. So what will be the answer? So here the answer is directly coming 0.1 mm. So this is the shortest formula for calculating least count. So both the method are same. Means by both the method we are getting same answer. We want to convert mm into centimeter. That will be equals to 0.01 centimeter. Okay. So this is what I mean to explain. This is your second method for calculating least count. Okay. And this is your first method for calculating least count. Now let me represent your X and N here. So this value, okay, this value, distance between two division on main scale, this is actually X. Okay, this length is called as X. And the number of divisions you can see here, count on Vernier scale. 1, this is 1, then this is 2, like this if you continue, 3, 4, 5, 6, 7, 8, 9, 10. So here how many divisions are there? Total 10 divisions are made on Vernier, and that's why they are doing X by N, that is 1 mm by 10, and your answer is coming 0.01 centimeter. Okay, now you can learn this another formula also. If anybody is having doubt, they can ask now. I have already unmuted you all. No problem. Fine. So we'll going to march forward. One of your friend is having doubt. N stands for, so N means number of divisions on Vernier scale. Okay. Hope your doubt is clear. Now let's come to the textbook part. We have to move forward. Just a minute. Let me clear that all. Okay, let's start further.
Calipers. A vernier calipers consists of a long, thin metallic strip called the main scale. The main scale is graduated in centimeter and millimeter. Each division on the main scale is equal to 1 millimeter. This metallic strip is provided with a jaw, J1, on the lower side at its end, which is called the fixed jaw. The metallic frame on the right side of the fixed jaw slides over the main scale, called the vernier scale. On the bottom edge of this frame is a graduated scale. It usually consists of 10 equal divisions that coincide with 9 main scale divisions. The value of each vernier scale division is equal to 0.9 millimeter. This vernier scale is provided with a jaw, J2, on the lower side, which can move with the vernier scale. This jaw is called the movable jaw.
Okay, so what we are learning? We are actually learning the different parts of vernier caliper. So here, this J1, it is called fixed jaw. It is actually made with the main scale. Whereas another jaw, J2, okay, it can slide over the main scale. And that's why this is called as movable jaw. So when we have to take any measurement, your object is generally fixed between the two jaws, J1 and J2. Let's see how they are doing this.
The vernier calipers is also provided with 2 more jaws, J3 and J4, on the upper side. J3 is attached to the main scale and J4 to the vernier scale.
Now here they are trying to say that J3 and J4 they are also jaws. Okay, J3 is fixed with the main scale and J4 it actually slides with the vernier.
A screw S is attached to the main scale. It is used to fix the vernier scale at any position on the main scale. The jaws on the lower side, J1 and J2, are called the external jaws. These jaws can hold the object firmly and help to measure the length of a rod, diameter of a sphere, and external diameter of a cylinder, etc.
Okay, so this way we can fix the object between the two jaws.
The jaws on the outside, J3 and J4, are called the internal jaws and are used.
Now they are trying to explain us that if we have to measure outer diameter of a solid body, then we are going to make use of outer jaws. Whereas if we have to make inner diameter of a cylinder, then that time we are going to use internal jaws. Okay.
Measure the internal diameter of a hollow cylinder. A thin and long strip T is attached to the vernier scale at the back of the main scale. This strip is called the tail and is used to measure the depth of hollow cylinders and small beakers. Further, the main scale and the vernier scale are also graduated in inches, which helps in measuring dimensions in inches. Let us now see how the length of an object is measured using the vernier calipers.
Okay, now they are going to teach us how we have to make measurement using vernier caliper. But before starting that, let us see what is given in our textbook. So if you see here, we just now talked about list count. The formula for list count is value of one division on main scale upon total number of division on vernier scale. This is the formula, but finally the answer we all know, and the answer is coming 0.01 centimeter. Okay, you can see here the answer is 0.01 centimeter. This is the list count of vernier scale. Hope your doubt is clear regarding list count. Now what is the definition of list count? So it's already given in the textbook. List count means the minimum value of measurement that can be done with the instrument. It is said as list count. Now next question, suppose we are asking what is the use of vernier scale. So here we can make measurement, okay, with great accuracy with the help of vernier scale or vernier caliper. See, you can see if you want to measure the length of rod, you want to measure the diameter of the sphere, or if you want to measure the depth of a beaker or bottle, then we can use vernier caliper. Okay. Now next thing is the use of vernier scale. So if you're talking about use of vernier scale, means this, the sliding part that is made on the main scale. Actually, it is the main working principle behind giving us the greater accuracy as compared to the common scale that we are using. So this vernier scale is actually used for specifying the accuracy of measurement. Now how your measurement is done, we are going to learn that. Okay, just a minute. So here some steps are given that we will see in the video. But before that, in our textbook, there's a definition of list count is also given, this orange box. So this you're going to learn. Means I'm going to give the solution of exercise 1B. So there this same definition will be there. You can read now also. The list count of instrument is the smallest measurement that can be taken accurately with the instrument, that is said as list count. Okay, now let's come to the video part. How we are going to make measurement with the help of vernier caliper.